So basically, this next chapter is all about testing. So we're gonna learn about, let's see here. I think says unit tests, fuzz tests, testing update functions, and testing view functions. So I don't really know how to do this. This might be useful for our other project for HTTP tests as well. And then after this, there's a few more chapters on like probably adding features and stuff. So we'll see how this goes. I don't really know what the sort of going bigger stuff is. All right. So first things first, I basically I copied the chapter 5 code to chapter 6 because basically this is it compounds on one another. So yeah, here's chapter 6. So this is all about testing. So apparently the first thing we do is we run elm test init. We'll see what that does. Here is my plan. Yes. Okay, so we have tests. Okay, the good news is it picks up our tests. Okay. So just as a reminder, excuse me, we have this Elm Live server sitting over here, which you won't see, but and then over here we have our actual application. So the idea here is that we have this this application that reads some photos and applies some grooviness to it. So we can I think we can turn all this stuff off, and that's like the original photo. And then as we move this, we set the dials to 11. We get a mess basically. So I changed these to like 2 by default, so it's mostly visible. So like one thing that gets a little funny is like if I do this, it can take a bit to catch up, but that was pretty fast. I think Ripple's a little slower. It's still pretty responsive. That one's worse than the other ones. So it might be nice to change this such that like when you're just being crazy, you can just wait till it stops before you do it. One other interesting thing would be like adding arrow keys. Oh, that actually works. I wasn't expecting that at all. So you can use your arrow keys as well. I don't know why you get that, but apparently that's a default. So useful. All right. So we're gonna call change this to photo groove tests. Okay, and then I presume every time. Okay, and then we're gonna move tests, example, tests, photo groove tests .elm. Okay, so in theory, the type checker should be happy now. Or, well, LSP. I guess it's doing type checking. Okay. So this is an example suite test of a unit test. Term unit test means different things depending on who you ask. So here's the definition. In Elm, a unit test is a test case that runs once, whose test logic does not perform effects. Okay, so unit tests are testing pure code. We'll contrast unit tests with fuzz tests in a bit, sure. So every unit test requires a single expression that evaluates to an expectation value. So I guess we write the following. expectation expect dot equal 1. Okay, so here's an example test that we could write. I've never used test in here, so we're just trying to figure this out. So equal has type A to expectation. Okay. Okay, so we can actually put this here, I guess. So test 1 plus 1 equals 2. Given some input. Hey Freeman, what's up? Expect equal. Alright, so this is a test apparently. And then we can see if it passes. So Elm test. Pretty slow, but. Test run passed. Cool. So that's a basic test. Nice. Yeah. Your stream was pretty short then. Like 2 hours or something? Did you end up getting everything running with Windows Subsystem for Linux? I had to step away for a while. What? This was supposed to fail? That doesn't seem correct. Ah, I see. Yeah, that happens. Apparently if you switch the argument order here, this fails. Let's try this. Oh, okay, you're not using Subsystem for Linux. Oh, that's kind of funny. The book says test run failed, but the code should actually pass. I was like, I can't imagine by flipping those arguments somehow this is going to fail. Which isn't surprising at all. All right. So the first argument to test is the description of the test. If the test fails, Elm test will display text to let us know which test failed. Elm test enforces that they must be unique. Okay, the descriptions must be unique. I don't think that this is all that scary. I presume that you can pass some input to these things, and then not using. Okay. Yeah, it's probably going to make your life a little easier to deal with a lot of things, actually. I haven't used Windows in a while. Well, not for development, so I have no idea what that world is like. Okay. Blah, blah, blah. So why the function wrapper? Yeah, we test this anonymous function, right? So here's this anonymous function. So why is that? It says this is done to postpone evaluation of the test. If we run both of these lines of code, let me show you the code, otherwise this is going to make no sense. So something like total A equals 10 plus 20 plus 30. add nums. So comparing these two lines, total A will immediately add 10 plus 20 plus 30 to get the result of 60. However, add nums will not do any addition yet. That line of code only defines a function. The addition won't happen until the function gets called later. The very first release of Elm did not wrap expectations in functions like this, which led to a problem on large test suites. Elm test would print something like starting test run, followed by a blank screen, followed by a pile of output only after the last test had finished. There's no opportunity to report progress incrementally. Okay, so by defining functions, we're sort of delaying execution. Interesting. So the test function takes a string, the string, and then a function which returns an expectation. I need to build Haskell editor setup on Windows 10, Linux, and Mac OS. So using Windows 10 is two birds with one stone. Oh, because you can build 10 and Linux at the same time. I suppose that's true. Okay, so that's an example test, and they're just explaining why the type of test is the way it is. So that's like a basic sanity test, I guess. So take a look back at Photodecoder. So let me bring this up in a vertical one. Photodecoder. So I'm trying to remember exactly what this does. It's decoding JSON, probably, and it requires URL, size, and title, one of which is optional. So I think that's how this works. So you're going to get URL, string, size with an integer, and an optional title that's a string. And then this decodes this into a photo type, which is... oh, right above it, you can see it right here. And I guess, oh, this must be the thing that's used when this is not available. What's up, school bus? How's it going? How was your day? We are starting with Elm test today. I want to finish this book because I don't want to have this open project while I'm doing other stuff. I'm going to get to the point where I completely forget how to do this, and then, you know, I'll never finish the book, and that's no good. I want to make sure I do. All right. So we're going to write a test for this code that checks whether that optional field is serving the purpose we expect. Namely, that if the JSON the server sends us doesn't have a title field, the photo ends up with the default field of untitled. Yep. However, our test can't yet access Photodecoder. Let's add this to the top of PhotoGroove test right above import test exposing So we need to probably import PhotoGroove exposing photo decoder. Okay. So apparently at one point there was only a main in here, but I've changed it to ... for whatever reason. So it's a little easier to deal with. Okay. And then down here we can write a separate function. It looks like so. So sort of we'll write decoder test decoder test. Oh, and then like Elm always puts multiple things between here. So we're gonna say title defaults to untitled. And then we have the beginning of our function. And let's put this down here, I guess. And then there we go. So we need to put some JSON It's kind of nice that it formats it like that. Earl fruits.com. Don't ask me why it's fruits.com. I have no idea. Size 5. In decode string photogroove dot decode photo de Okay. So this should be title What's up, Altern? How are you? We're working on some I think this is right. Oh, and then I have to finish the parenthesis for the anonymous function. Decode string. I'm not depressed. I think I'm doing okay. I got a bunch of stuff going on this weekend, meeting friends and stuff. So I hope that will be good. Where do we get decode string from? JSON decode. So 6G import. It's right here. See. JSON decode. JSON decode exposing decode string. Expect equal. Oh, I see. JSON. There we go. Okay, so basically we have some example JSON. So it just is going to give URL and size. And then, you know, the result should put this entitled or this untitled thing in here. Yeah, yeah, that happens. I mean, I understand, like, yeah, I don't know what to say to that. I'll leave it alone. Hey, Jappy, how's it going? Nice stream, by the way. OK 200. I'll write a test to return OK 200. But not with COBOL. Okay, so that's an example. Yeah, that was pretty funny. I enjoyed watching it. I hope that actually helps you instead of, you know, leads to nothing. I mean, at worst, it's fun, right? Not a lot of people write COBOL anymore. Okay. Oh, apparently we can write this a little cleaner. Elm has a triple quote syntax for longer strings. Nice. So instead of this nonsense, we can instead write you want me to buy a house? Could you add a custom reward to buy with channel points for a house? I assume you mean buy a house with channel points. Oh, a virtual house. Like in, what is that game people are playing right now? Animal Crossing? Alright, so we can write JSON this way. And I suppose we can even probably prettify it. Prettify it? Prettify? How do I pronounce that? Can we do this? I mean, it seems to compile. It doesn't mean it's going to work. So we'll see if it works real quick. Elm test. Running 2 tests. Passed 2. Seems fine. So that's kind of nice. We can write JSON in a little slightly nicer syntax. I don't really know if this is, considered the nice way to do this. I think it spreads out the results. It cleans this code up a little bit, but maybe it doesn't make sense to actually abstract this stuff out. It's kind of nice to see these before you see this, but maybe not. I don't know. Okay. That's cool. This is nice. I couldn't imagine having to write, like, you're probably going to copy and paste examples from other places before you even start, so I could see how that would be useful. Our test expects that decoding this JSON will return wait, what? Oh, okay. I probably just copied something wrong. Oh, so in the book, he writes title with just quotes here, because, we're kind of saying that this would return title empty, but that's actually not true. So if we wanted this to fail, we could just change this code in here and then do Elm test again, and it will fail. Yeah. Oh, this is really nice though. Okay, title not equal this thing. So nice. So untitled. Did I actually fix channel points? I don't even remember. You cannot cheer in your own channel. Okay. Oh, that's cheer. I don't see channel points here. Why not? It's very confusing to me, but anyway. All right, so there's our first test. What's next? Okay, so we wanna test that this actually fails, probably. Okay, fixing the failing test. It's very confusing. I don't know if this is the final copy of the book or not, but there's some mistakes in this chapter, but that's fine. It's useful to start with an intentionally failing test and then fix it. Okay, I've never thought about that. We can use some syntax to clean up some of these parentheses as well. So we could write the following instead. And we don't need those parentheses there, which is kind of nice. I don't know if that's a huge improvement, but I mean, I guess you can attach this here and then just do the following. Although Elm format might change it a little bit. That way that line ends up being the same every time. Okay, neat. Narrowing test scope. Our test description says titles default to untitled, but we're actually testing much more than that. We're testing the structure of the entire photo. It means if we update the structure of photo to say add a new field, this test will break. We'll have to come back and fix it manually when we wouldn't have needed to if the test did not rely on the entire photo structure. Even worse, if something breaks about URL or size, we get failures not only for the tests that are directly responsible for those, but also for this unrelated test of title. Those spurious failures will clutter up our test run output. We can refactor this to work on title only by introducing a function called result.map. That's cool. Okay, so we got this. We're going to decode this, and then we're going to result.map photo.title. What did I do wrong? Oh, I'm missing a... There you go. All right, so we take the photo, we rip out the title, and then check that it's untitled. And again, it's going to be inside the OK status instead of the... I don't remember what the error status is. We would have to find out if we could get this to fail. I assume there's a way to make it fail on purpose. And this OK is a result. Ooh, right. We have this. Maybe we... Can I not look at the type of OK? Can I look at the type of anything? Apparently, comma D does not work in here. The errors show up, but I can't do that for some reason. We could do result. We could do okay. Elm documentation. Official. Result. Okay, or error. There we go. All right. Okay. We can make one more refactor to our test. Take a closer look at the anonymous function we're passing result.map. Oh, nice. There's a shorthand for this that's literally just .title. So that will rip out the .title from the object. I see why people like this language, because there's niceties like that. I mean, I guess that's very similar to a section. Wait, no, you can't do that in Haskell. It would be slightly different because you would just have the name of the constructor to pull out of it. But then you don't have the ability to extend the types. What is this called? Row? They're called row types or something? I forget the terminology. But you can have many different, you can just add stuff to them, and all that needs to be true is the piece of JSON has to have a title, which will always be true because of the decoder. It might not be a string, so it could fail. View title. Yeah, this, oh, I see what you're saying. Yeah, it looks like a lens, basically. Okay. Do. Yeah, so anyway, the key is, or one key, was it get? It's view, yeah. It's called a getter, right? The function is called view. All right, so it works and it looks kind of nice. I almost wish that this was all indented under the in, or that this was put under the let. That looks kind of funny, doesn't it? Also, I feel like this let is probably unnecessary now that we have this nicer syntax, and we're also not letting multiple things. So we can probably just do this. Why would you ever... Well, I guess it won't know how to format this stuff. What if we do this? Okay, it doesn't put it back, so that's just in our... We just have to format that ourselves, which is not that surprising. Yes, it does, Jappy. The first chapter of that Optics by Example book, he went through like really insane examples of stuff you could do with lenses and optics, and I was blown away. Like like he had an example like the following. It was like something like this, but nested in an even more weird way. And he wrote a lens that sorted the characters in place. So it would end up being ABC, CG, HG, and then XYZ over here, right? Like that kind of stuff seems really powerful. I mean, obviously it's not the most practical example in the world, but the fact that you can write stuff like that is pretty wild. I could see how it'd be really useful doing data analysis workflows. So like it might be really cool to have a sort of a data frame library, if you're familiar at all with data frames in R or Python, in Haskell using lenses. I could see how it would be really useful for me. So I'm pretty excited about that. But we're taking baby steps. Yeah, so I mean, the data frame abstraction in Python, I use it every single day when I'm doing data analysis work because it's just so easy to do. And I could see, I could see myself using it a ton. Nested records, yeah, like anything with like a relatively complicated structure, I can see how optics would be useful. Also, hi, Ken. How are you? Also Ken, another Ken. Hi Ken. I don't think I recognize your name, so hello. I'm glad you found us. We're learning about Elm and functional programming in general. Right now we're doing 2 books. Yeah, I could see how, yeah. I've never used, I don't know if there's an optics library for Python, but there probably is. I suppose you wouldn't really need them just because of how, well, actually that's not true, because accessing data frames is actually really hard for beginners. I struggle a lot teaching people pandas because you have to write these really complicated accessor patterns. Maybe there's a lens library that would make that easier. I don't actually know. Anyway, okay. We got this decoder test, and we've written some relatively clean code, I would say. It's not that hard to read. I didn't know about this triple quote syntax, which is nice. And then we got some functions. We like functions on this channel. All right. We're testing only this one particular hard-coded JSON string. Next, we'll use fuzz tests to expand the range of values our test covers without writing additional tests by hand. And I suppose fuzz tests kind of mean like property tests, where we're gonna build like arbitrary chunks of JSON. I don't know what the right term is, blocks, something like that, and then pass it to our decode string function to make sure it works. So I would have always called these property tests, but oh, okay, here. So it says sometimes called fuzzing, generative testing, property-based testing. So yeah, cool. I should always read before I start talking, but usually I do the opposite, so it is what it is. All right, so converting unit tests to fuzz tests. We need to replace our hard-coded JSON string with some code to generate that JSON programmatically. Building JSON programmatically with JSON encode. Just as we use JSON decode to turn JSON into Elm values, we can use the JSON encode module to turn Elm values into JSON. So I assume we're going to just generate random values in Elm and then encode them and go from there. So the encode module, JSON encode, centers around the value abstraction. A value represents a JSON-like structure. In our case, we will use it to represent actual JSON, but it can represent objects from JavaScript, like the JavaScript event objects we decoded in chapter 5. I don't remember doing that, but okay. We use 3 functions to build our URL, or like our JSON on the fly. Based on the type, it generates random values. Yeah, exactly, Ken. So if you've never done like quick check style testing, it's a really powerful tool because you can basically stick all kinds of random stuff in here, and they can be random strings. You can use them to test all kinds of interesting stuff. So as examples, we usually use them I've used them in the past to test properties about whether things are functors or not. That's a good example. And we've written these interesting quick check things to make that happen. So yeah, we'll see how this looks in Elm. I don't actually know. Well, it should be a useful idea in any language that you have. I presume you can find a quick check style library to use. So we'll see how this looks. All right. So we have this fuzz library, which is interesting. This isn't using this fuzz library, but it seems to me like we can get int string from this fuzz library depending on what it does. So maybe we should pop open the REPL and see if we can figure it out. I forget how to do that. Is it just Elm REPL? Okay, good guess. What's up, Pretz? How's it going? So now we need to import fuzz, exposing everything probably. What? Oh, maybe I have to, yeah, Elm today. Maybe I have to like somehow point it to the fact that I'm using the test side of my project. Elm REPL help. No colors. Elm. Is there a way to use a different config or something? I don't know how to open the Elm REPL with that without just adding it to, if I could spell. Actually, let's do it over here. It's fine down here. Oh, but you can't see it. Sorry. Anyway, I assume that it comes from here, so we'll just stick this into direct and put a comma there. And then wish I could rotate these. So let's move this down here and then use this one for Elm REPL. Okay, so now can we import fuzz exposing? Yes. Oh, error. Okay. I broke it. Maybe I just do... Yeah. Okay, finally, we got fuzz. So if we just type int, let's see what happens. We get an OK generator of function. Interesting. Okay, we'll see what happens here. Maybe they'll call fuzz here in a second. Okay. Oh, yeah, we're talking about fuzz now. So they just showed an example of you taking an Elm object that was just like this and then encoding it, but I don't think there's any reason to write like the version of this that just uses encode. I feel like it would be relatively trivial. So let's actually write a decoder fuzz test. Test fuzz. I don't know what to write here. Let's see what they write. Oh, we need to write. Oh, we need to write fuzz2 apparently. Fuzz2. Oh, that's in our... That must come from here? Where does that function come from? See how it says fuzz2? It takes two fuzzers and then an A to B to expectation. Okay, so like this is our function here that will... We're basically going to write something like this, and we'll use encode to create the JSON object. Okay, so fuzz2. It could be defaults to. And what we'll do is we'll comment this out. What did I just... I have no idea what I just pressed. Okay, so that's that. So we need two fuzzers. So we need first, I guess it doesn't matter which order, but we need a string and an int. And then we need a function that takes two inputs. So it's like URL and size. And then we need to return an expectation. So we're going to create an object. Can we just do URL decode object. I don't know if we can actually do this, so not sure. And then decode value PhotoGroove dot photo decoder, and then result dot map title, and then expect equal okay untitled. Let's see if it compiles. Oh, well, we need encode. So import JSON encode exposing object. And we also need decode value, so that replaces this. And then we also need to change JSON decode value. Okay. Encode, oh, first of all, it's JSON. Okay, so yeah, this part I don't know. Oh yeah, this is nice. Fuzz2, so what we need to do. All right, well, anyway, we'll just do this the way that they have it. So it's a list of tuples, like so. Then we'll see if this works. I see. So 6G, this has to be like as encode, so we don't have to type JSON encode. And I think we can write all this. Oh, I also need to do photo object string int, and I don't remember, wrong button, this button. Oh, I gotta put the as in front. JSON encode as encode exposing. Okay, so something like this. And this probably needs to be fuzz dot string fuzz dot int. All right. So what's wrong here? The order, obviously, because this clearly goes last, right? So you could build combinators of fuzzers. There we go. So it goes the first fuzzer, that's the, well, also it's the same shape as this, I suppose, but I don't know, maybe this should go first. Not sure. I suppose you could use fuzz2, fuzz string, fuzz int, and then have different titles based on this. So that could be useful. How does this format? Okay, we just create a little more space. All right. It would be really nice if we didn't have to write this, and we could just write like URL equals URL. Let me show you what I mean by that. maybe I have an example over here. Now these are like updates, but I think you can create trivial objects as well. Yeah, see, like this. So this is like an object. It would be nice if we could just create the object like this and then just encode it with the name here, but maybe that's just not possible. Although maybe we'll learn about it here in a second. So anyway, here's a fuzz test. Very fun to say. We'll see if it passes. Elm test. I spelled it wrong, probably. I did. See, error there. I intentionally did that to see if it would fail. Did I not? You can't prove it. Alright, and then in theory, I guess this should pass. So running 2 tests to reproduce. How many times did it create? Okay, so it creates 100 times. So we can run something like 5,000 to see if it fails with 5,000 inputs. So this is kind of how this works. So you usually have to give these like inputs, then it'll create 5,000 random inputs and then pass them to our test. In this case, it doesn't matter what we give. We're always going to get that title field is untitled. And then if we could also write another test, which I'm just going to write even before we get moving. So we're going to write a similar test here. So this is like default title decoder test. I have no idea what's it. We probably don't need to write test next to it either because it has test as the type. So default title decoder, something like this. And then what we could write here is something like title decoder. Title decoder. And so this one is going to take a fuzz3 and we're going to say fuzz.string because title is a string. And then we're going to say title parsed correctly. I don't know, something like that. And then this time we're going to have a URL, a size, and a title. And then title is going to be encode string title. Then we're going to encode the object, feed it through our decoder, rip out the title, and the titles better be the same. So we could write OK title, I suppose. And then this would test that every time I create this, that this title ends up being the same. I suppose you could expect that, you know, just create the object as well. I don't know. Something like this. Does that make sense? So there's a second fuzzer. Or property test. Hopefully that's interesting. Hopefully you're still here. I don't know. Okay. So there's an example. So it says testing update functions. So over here we have an update function that does a whole bunch of stuff. So for anyone that was watching last time, I had a bug in this code that somebody on the Elm forums helped me fix. It was this line right here, 230, 231. Basically, when I was receiving the photos, I wasn't updating the status to tell it that the photos were loaded, which is why I had to press a button before it would happen. So once once you have this with your apply filters function, then it will end up working the way you expect it to. So again, if you haven't seen the application yet, this is basically what it looks like. It's just like you click a photo and it adds some stuff to it, and it's like you can make it really ripply if you want, or not ripply, really noisy, etc. Or you just look at the image. So that's what it does. Okay, so testing update functions. So Elm programs share some useful properties that make them easier to test. The entire application state is represented by a single model. The model changes only when update receives a message and returns a new model. Update is a plain old function, so we can call it from tests like any other function. Let's take a look at the type of update. So there it is, 208. So you can see I'll highlight it there. Yeah, that was the bug, is this stupid little line of code here. And I should have written some like some tracing or something to show, or to think about why, like the steps that we're going through to and be more careful. But you know, I missed a line of code in the book and it causes issues. I've had that happen to me before. So but yeah, if we just refresh the page, oh well, apparently we can't just do that. This button, there we go. And then if we refresh the page, oh my gosh, it just loads up, and once you change, everything kind of just works. Very purple. I like it. Okay, so that's all running. There we go. So update. So message, model, and model command message. This is a pure function. All right. So we're going to call update in a test, passing the message and model of our choice. Examine the model it returns. Let's use this technique to test one of our simplest state changes when a slide hue message introduced in chapter 5 comes through the application. For reference, here's the branch. So let's just quickly look at this 239G CT. All right, so when we get a slide hue message, we're going to get a mount, and then we're just going to return an update after this apply filters function, which I presume won't matter. This is something that passes off. Apply filters passes stuff off to JavaScript, so no, it doesn't. It just updates the model again. And actually, our first state will probably be loading, so we'll see how this works. I don't really know how this is going to work right now, but anyway, that's the function that we're attempting to test is not apply filters, slide hue, in our update function. Okay. This might seem like a trivial thing to test. It does so little. Oh, it does update the model's hue, right? Well, not quite. The logic also calls apply filters. What if apply filters later returns a different model, introducing a bug? Even writing a quick test for slide hue can give us an early warning against that and potential future regressions in our update implementation. The following listing shows a basic implementation which combines several concepts we've seen elsewhere in the chapter. Okay. So slid hue sets hue. So I assume that this is going to be similar to what we did before, where we're going to say, like, don't worry about the rest of the model, just make sure what you get back is an updated hue to whatever it is. The other interesting thing from here is that, you know, we don't have a slider to play with, so we'll see how that ends up looking. So fuzz, we're going to do a single fuzz, and it's going to fuzz. It's going to take an integer and the name of the test. So it's not called slide hue, it's called got slide hue. Slid, right? It's in the past tense. So, whoa, Simul iOS. I'm not Simulus. Thanks for the big raid. Really appreciate that. Hey, yeah, we do Haskell on Tuesdays mainly. Right now we're doing Elm on Thursdays. So I kind of work through books. That's like my thing. So right now we're working through Elm in Action. So you can see there. So you can get the book. It's a Manning book. So it's not super expensive, I don't think, but you can get the book. It's pretty nice. There's a few errors in the chapter I'm working in, but they're not, like, they don't break the book at all. And then I put my code on GitHub, and then also I have code on YouTube. So if you wanted to see like the past examples, you can just check it out. So thanks for hanging out. How do I say your name? Simulus? Simulios? I'm not entirely sure. I'm just guessing. But thanks for the raid. I really appreciate that. So we wrote some property tests. I don't know if you're familiar with property tests. What were you working on? Simulation, but Laos. Simuleos. Okay, I can deal with that. Yeah, that makes sense. I got it. What were you streaming about? I'm not sure I caught your stream before. I like new streams. Also, Simuleos, thanks for the follow, and D Karmic, thanks for the follow. We were working on fractal animations and algorithms related to them. That sounds really fun. Yeah, Prutz always makes fun of me for my pronunciation. I have a hard time pronouncing words. It's apparently an English speaker problem. I didn't know that. Do you have a particular language you're working in? That, just out of curiosity, I don't know what your viewers are into. Yeah, I got it once you gave me the classic bunch of languages. Cool. All right, so anyway, we're building some property-based tests in Elm. So that's basically what we're doing. So this particular one is testing I just want to give you an example so you can see what we're doing. You can decide if you want to stay or not. We have this photo decoder, which basically just tries to read in some JSON that contains URL, size, and optionally a title. And then it turns that into a photo. So in Elm, you have these records that basically look like records in other languages, but they're a little special because you can actually, anytime that you could take a photo, you could also take something like a URL size title and like an additional field. So as long as it has URL size and title, it will still behave as this record. So Elm is kind of cool in that regard. Right now we're doing a slightly more complicated one where we have this update function. So basically the update is the heart of your application. Whenever you do anything in an Elm application, it basically turns into an update. So this is that function, and we're trying to write property tests for update. So that's what we're working on. So we have this fuzz thing. We're going to take an integer, some integer to pass. I assume this is going to represent our amount. Yeah, and we're probably going to artificially generate a got slid hue message and then do something with it, I suppose. So, yep, that's exactly what we do. Got slid hue sets the hue. So we're going to say, here's our amount. So that's our amount. And then we're going to say, take our initial model, pass it to update. Oh boy, that's not what I wanted to do. Pass it to update with got slid hue amount. So this is our message. So we can see our type over here. We're going to take a message and a model. So that's what this is doing. This little arrow says do this with this as an input to that function. And then we're going to check that our update works, we're going to pull out the first piece of our tuple. So if you look down here, you can see, well, it's not that obvious, but we're going to get basically this back. So we're going to have a model and a command message. We're going to completely ignore the message and just check out the model. That's what the tuple first is doing. And we're going to select the hue, and then we're going to expect that the hue is equal to the amount. So I think this will work. But we need to get these things from PhotoGroove. So our application is called PhotoGroove, and we need initial, model, and update. And we also need our message, got slid hue. But maybe we just do this. And see if anything else breaks. It's not always great to expose everything. You can see that even there's like a warning about this here. Yeah, that's exactly right, Prutz. So you can pass things left or right based on your triangle. Yeah, so this we're using as an input to this function, and all of these we're using as inputs to the following functions. But yeah, it behaves just like ampersand, the right one. Or the greater than version, I suppose. I'm gonna go with copatend, something like that. Thanks for the follow, really appreciate that. Hopefully you learned something, and if not, hopefully you teach me something. But yeah, building chains and stuff like that in Elm is really easy. It's a little more difficult in Haskell. You just gotta think backwards most of the time. Okay. So yeah, this doesn't look all that scary to me. Well, it says it's not supposed to compile, but it does. We'll see how that, maybe it will, the test will fail. Let's find out. Elm test. They just pass. Okay, let's keep reading, see what this is. Oh, okay. So the my code is a little bit different than the code he has. So up here, if you look, I have PhotoGroove exposing ... and I'm not exposing specific functions in here because it's just easier to work with in this case. So the code that he has written in the book won't compile because he doesn't expose all of the messages and stuff. So that's why this will fail. But we have ... here, and then we just import everything. So we have everything available that we need, and that's why this just works on the left. Okay. Left triangle is like $. Yes, I believe so. Minus probably some semantics with the way it behaves. Although I don't know entirely. It might behave exactly like, they might behave exactly like those functions in Haskell, but I've not done enough testing between the two languages to explain the caveats of their behavior, if that makes sense. Okay, so we don't have this problem. Making... Okay, so we did that. I'm a little confused. Because it says that it's not supposed to work. As of this writing, Elm test does not support testing commands directly. However, you can work around this if you're willing to modify your update function. But we didn't have to update our functions, so it seemed okay. Not entirely sure what this means, if it means anything. It's not skipping it because we should have 4 tests to do. I'm not sure. Maybe when the book was written, this was not capable, or this was not possible, but now it is. So we just deal with it. All right. There's an additional function we can use to pass multiple tests. So we could write a function like test sliders, which takes a string, an int to message, a model to int, and returns a test. Does anybody have any questions about like Elm? Like, hopefully this code's not blowing your mind. I know that this kind of syntax looks very different from a lot of other programming languages, so feel free to just ask questions. I'm willing to try and answer them as best as I can. Clean Star, thank you for the follow. Appreciate that. Why did Elm make Haskell syntax? Well, that kind of question I can't answer, Strager. Sorry. I don't know the design decisions. I think my whole guess with most of the stuff in Elm is that the decisions are made for people coming from JavaScript, not people coming from Haskell. So when you come from Haskell to Elm, you're going to lose power. But if you come from JavaScript to Elm, you gain power. So I presume that this is modeled more after JavaScript, but I don't write JavaScript, so I can't. Wait, there's no modules in JavaScript, right? Not like this anyway. So I don't know how to answer that question. That kind of question I can't answer. But I can't explain, well, some things. Not a lot of things, I suppose. I'm kind of useless. In terms of type level power, yes, because in JavaScript, everything is an object, I guess. And then in Elm, you have more complicated types, and then something like that. Yeah, I like Strager's more. Yeah. So if you're talking type level power, then it goes clearly JavaScript, Elm, Haskell. I mean, there's a lot of other languages in between, but depends what you're trying to do. What do you think is important? And you could talk about a lot of different parallels where that order is reversed, I suppose. But I'm not going to worry about that too much. All right, fuzz int description. Date to message. So basically what we're doing here is abstracting over the message type so that we can reuse it. And this is the kind of really powerful stuff you get to do in functional languages that are very easy to write. And for reference, the autocompleter that's in here is just Haskell IDE engine, or sorry, it's Elm's version of LSP, but it could be hard to read. That's true. I guess you have to get used to it, right? If you're not used to the syntax, then everything's hard to read, but that's a fair point. But then we can rewrite this function, right? Like sliders, test. I suppose we should put this underneath. We usually read things from top to bottom, although it doesn't really matter. To Elixir, interesting. I've never written Elixir, but I've written a tiny bit of Erlang, and I guess there's some comparisons if I remember. Yeah, it's like, I always think it looks like Haskell, so. Ish. There's a few major differences, but. Desired field in the model. And then we can put things in here and say test sliders. I guess we put got slid hue. And then this takes a toMessage function, which is supposed to be what? Oh, right. Got slid hue, and then the selector for that thing. Test sliders. Got I think they're all got slid ripple dot ripple. Hang on, I gotta remember what this is. Ripple. Yep, you can see it here. Hue, ripple, noise. So it is dot ripple. Test sliders. Got slid noise. Slid noise dot noise. All right. So equals actually means equals. Yeah, I don't know, Strager. I mean, yeah, some amount of indirection is definitely hard to read, but I think these function, it's more like, I think it's more like a lens. We were talking about this earlier. I think it's more like a lens, but it behaves like the function, it's like a getter. So if you had like model dot hue in this case, that's how it behaves. So I guess it's like a getter, so a lens, but you're not calling view, so dot hue. And we don't really need this function anymore. Is this referred to as record syntax? Which thing, Prutz? Give me a line number. This dot, I think these are just helpers. I guess there would just be called sections, like in Haskell, but maybe lens is actually more appropriate. Or getter, something like that. Let me see if they give me a name for this. Hang on. Where is it? Narrowing test scope. It's got to be here. It just says dot. Functions like this come up enough that Elm has a shorthand for them. Writing dot title by itself gives us a function that takes a record and returns the contents of its title field. So yeah, it's a shorthand is like a section, but it only, like, its input is always a record. So it like the input always has to be a record that would contain the object or the field hue. Yeah. But there's no specific name. It's just like desugared to, you know, a to a dot hue. But I think section might be a good term for people coming from Haskell anyway. For people coming from other language, I suppose section doesn't help you at all. But I showed you an example. Ostermint, hey, how's it going? The horizontal white space matters. Yes, I think so. If we try and stick this over here, yeah, it's gonna complain unexpected symbol. I don't know how far it needs to go out for it to stop complaining. Probably maybe here it will be fine. Yeah, we get rid of that. Let's see if it complains. Okay, so actually it only needs to be one space off. But the formatter will sort of move stuff for you, and like by default Elm puts in a ton of white space, like horizontal white space. Got slid hue dot hue is different from got slid hue dot hue. Yeah, so this is a type. So if we look over here, let me find it here. It's just like a data constructor. So this is just a data constructor, whereas this is an accessor or a section that grabs a piece from a model. These are completely separate concepts. I mean, they happen to be connected because they're both discussing hue, but they're, you know, this behaves on a model. So this is like a model to string, or sorry, model to int, whereas this is a message type. Yes, for sure. We can prove it. Well, that would be an error here, but I see what you're at. You're asking a different question. You're asking the following question. If we open up our REPL and we, let me reload it, and we import PhotoGroove and we type got slid hue, you'll see that this is a function int to message, and if we try and write got slid hue dot hue, this is just going to be like, I can't find got slid hue variable or something. So naming error, weird error. So yes, syntax error. Okay. Yeah, Prutz has got it there. Apparently, it thinks that this is some method or function or object, something inside of a, what's the right term here? A module? Yeah, that would be fine. Yep, we could create an anonymous function, got slid hue to got slid hue dot hue or something, and you'll see that this takes a record that contains hue. So it has to be a record with a hue field. It can't just be any record. So there's a little, I think that this would be like if we tried to write this and pass it a function or a thing that didn't contain a hue, so we could say like, I don't know, example, if I could type 1. Why is that? Oh, I probably have to do, why is this complaining? What am I doing wrong? I'm doing something stupid. Oh, it's probably because I'm supposed to use equal. Yes. Sorry, I'm being silly. Yeah, it's equals. The type contains the colon, and for some reason I wanted to write the colon. So it seems like a record field typo. Maybe who should be example. Right. So it's like trying to help you because you wrote example, but it doesn't exist. It's complaining, type mismatch. But if instead we did hue equals 1 like that, and we wrote FA, then it would just give us 1 because hue is now a part of this record field, and we're okay. Yeah. Does this make sense? Hopefully this is interesting. If anyone's never seen Elm anyway, or even Haskell or row polymorphism, I think is what the term is here. Row polymorphism seems really cool. Both Elm and PureScript implement this kind of concept. All right. Anyway, let's see if our test passed now. So Elm test. They pass, so cool. We could probably make them fail if we wanted to by like replacing hue with ripple, and that would fail. Let's just prove it to ourselves. It should compile still, but oops, that's not what I wanted to do. Shoot. Try again. It should still compile, which it did, but it should fail when we try and do the test. There we go. We're back where we were. Elm test. Yep. So it created a arbitrary value 2, or I'm sorry, 2 is the default. So when we have our initial model, it's supposed to be 2, and we got 0, so it failed. Good. All right, neat. Okay, we talked a bunch about this. All right, so now we're going to talk about testing views. So this is like testing messages, basic messages, and now we can talk about testing views. So we're going to test DOM structure. What is it? DOM is document object model. Is that right? Model. Talal, thank you for the follow. I really appreciate that. Document object model. I've not done a lot of web programming at all, which is part of the reason why I'm trying to learn Elm in the first place. So if that wasn't clear, hopefully that helps. Slow piece of crap. Nice. Does Elm have where clauses? I put test sliders in a where clause under sliders. It has let, but not where. So we could do let test sliders in and then describe, probably. Like we could do the following, I think. I think this works. It appears it's working so far. Elm test. So any of the new folks, if you want to tell me what languages you're into, that would be cool too. I like talking about programming languages. I find them very fascinating. I don't know everything about all of them. That would be impossible, I feel like, but I'm trying to get better at them. We're doing mostly pure functional languages on this channel, but that doesn't mean I'm not interested in other languages. Also, it's interesting to know what people are working on, generally speaking. You can't deal with let in? Is that's not good enough? Honestly, I probably won't use Elm in practice either for reference, but somebody suggested that we start with Elm, so let in is terrible. Okay. All right. It behaves like where in this case, so yeah. Your really? That's interesting, actually. I wouldn't know. Like, I like where too. I don't know that I'd call it my favorite, but I do like it. That's an interesting statement, actually. Yeah, I mean, I don't know. This is fine. But you're right. Generally speaking, I don't see where we would use test sliders other than in this function. So it really doesn't make a lot of sense to define this function outside of sliders itself, or test sliders, or whatever I wanted to call it. Actually, that's a good point, Prutz. Top down. Okay, that makes sense too. Like you write like placeholder functions and then fill them in with undefined and then fill them in or something like that. That's usually how I write them. It's like, I know I need a function that looks like this. I'm just going to call it undefined for now, and then work forward. But I'm also a pretty inexperienced coder, generally speaking, so I tend to maybe do things different than most people. I know you've been writing code for a pretty long time. All right, so we're going to try and test DOM structure now. I mean, what was it? Slow piece of crap structure. Okay. So to do this, we need a few imports. HTML attributes as attr exposing source. Test.html.query as query. Test.html selector as selector. Okay. We've already done this part, so that's okay. So no photos. The first rule we'll test is this. Initially, we don't render any thumbnails. So in this case, the thumbnails are these things. So when we refresh the page, it's not obvious, but there's a split second where it doesn't know about these photos because it goes and loads information about them. So I think all we're saying is that for our initial model, there should be no thumbnail photos printed to the screen. I guess that's the idea. I write my code bottom up, but I want the text of the code to read top down. Okay, I think I understand what you mean. So Haskell is a great language for you then, because it really promotes that kind of style, which is why you're a huge fan of the where clause, I suppose. Breaking down your psychology, kind of. All right, so no photos, no thumbnails. These are terrible names, by the way, but I'm not going to be too concerned about naming right now because we're learning about concepts. But everything in Haskell sucks. I love Haskell. Is there such a thing as the perfect programming language? Because I don't think there is. But it doesn't exist. Oh, fourth, okay. Nope. Okay, so we take our initial model. Yeah, I've never written fourth either. So we're gonna use our view function, and then we're gonna query from HTML query.findAll tag count expect equal 0. Where is this supposed to come from? Probably adder. Let's use the documentation to try and find tag. What is that thing called? Tag. Selector. It's probably selector would be my guess. So there's a few typos in here, but they're not terrible. Like, you can use the documentation to figure them out, but you know, maybe that would be frustrating for folks that haven't programmed a lot before and they picked up this book. Like I've programmed a lot, but you know what I mean. I know how to look up the problems or ask questions, things like that. Okay. The first part of the let me put this up here and we'll talk about these 3 lines right now. So we're going to it builds a representation of the DOM that our test case can examine. And it's going to look for all image tags. So just as a, hello? Let me go show my view function. Well, really, we can just look for image. So you can see here that view thumbnail creates the image tag. And so we're just looking for these on the page. And if we don't find any of these, or well, excuse me, we shouldn't find any of these things for the initial model. That's kind of the point. So there should be no images rendered. Oh, you can see that. Okay. There should be no images rendered when we look at our initial model. Then I suppose what we're going to do is something similar to this, where we like just add an image, sort of a fake image, and then look for an image tag. Maybe something like that. I don't know. Okay. So query functions make use of 2 types as they descend into HTML. Query.single like capital single, that's like it represents a single DOM node. Query.multiple represents multiple DOM nodes. Some functions work in terms of single nodes, whereas some work in terms of multiple. Representing these as distinct types makes it easier to tell when we expect a query to have one result versus several. For example, the query.count function takes multiple, whereas the query.children function takes single and returns multiple. Fully understand what that means yet, but I suppose it will come up at some point. So we have this query from HTML, so that is what's, I guess, parsing our DOM, or the DOM model tree. I don't know what the right term is here. So image has several states. If an image is on a page, it might be in the unloading state, Are you sure you want to verify the absence of images and not the presence of images in an unloaded state? So in our case, here, let me show you kind of the flow here, and hopefully it will make more sense. So we have this view loaded function, and view loaded only happens when we get this message that our images are loaded. So by images loaded, it's really just go reach out to a server, ask what images are there, and then it will basically try and update them. So that's what happens is if we get a set of loaded images, so this is our status, if we get loading, which is like our initial state, there's just nothing here. So there should be nothing on the page, or we'll get an error message if there's a problem. And basically, yeah, exactly. So this initial model, if we just look at initial model, you'll see that the status is loading. Therefore, it will basically do nothing. So there's nothing on the page at all when we start, because this is like a single page app. And we actually don't know how many images will be given when we start anyway. Yeah. Does that make sense? Hopefully that makes sense. Okay, cool. All right, so I feel like this code is pretty readable from my standpoint. I mean, I have some idea of how to write HTML. I've just not written enough of it to be proficient at it. So like this seems like a logical flow to me. It's like call view, we're gonna return some HTML, parse that HTML, look for any image tags and count them, and there better be none. Like this is pretty readable to me. I have just enough experience with the web that makes sense. If you had none, it would be a little weirder. I don't know. All right, so I'm gonna skip some of this because I feel like there's a lot of explanation going on here. Oh, we didn't actually test that this works, did we? I don't remember. Yeah, for sure. Yeah, we would have to know how many are on our initial page, I suppose. But yeah, it's a pretty brittle test in that regard. I think they're just trying to show you that you can probably. We would maybe find, let's see, thumbnail. I suppose maybe we could put a class or something on this. What's the right term? Like you want to find an image, not just an image, but one with a specific tag. I forget the term that goes here. Again, not that familiar, but I suppose we could do something like that. You could ignore the images that are like base images versus thumbnails. Yeah, something like that. So we would find all the image tags, and then I'm not entirely sure what we do then. There's probably some other, we could probably just call find all again with like selector dot tag or selector dot class. Let's check out what's in selector. Given tag text. I don't know. I assume that this is like text containing. Okay, so here you go. You could use find all tag containing and then probably like class or something. ID, or I guess an ID. There's class. So I think we could do, yeah, something like this. Find all. Well, we can. I guess we can test it. Maybe we can test this. But I see where you're going. It would be better to do it that way. Maybe we should write that as a note. I'm over here. Wrong side. Might this test is brittle if we add images, for example, a logo. Trigger words. All right. We'll change this to note. Could be better to use selector dot containing. Yeah, don't write to do. Elm is triggered by to dos, folks. And selector dot class. And that's probably a fine note for now. Like, again, we're not writing production code here, but you know, that's a really good point. I'm not super in tune with testing, so thinking about this stuff is important. Ooh, good call. Let's try it. Nice. Yeah, it's not also a brittle tool, apparently. To space do different than to do. Nice. I still think I prefer note, actually, but it's kind of fun to mess with tools. All right, so now we're going to try and fuzz some view tests. So once a photo is loaded, once the photos load, we render a thumbnail for each of them. So let's start by writing a function to check whether a given URL has been rendered as a thumbnail. Thumbnail rendered. String query single no idea where that did. I don't remember typing that. Second A. URL query dot find all tag image attribute this is selector dot adder dot source URL prefix URL. Now, one issue with this is that the URL prefix is probably incorrect. Maybe not. It might be fine like this. And then that's not going to format yet. I have to finish the code. Query.count expect.equal1. I think this is right. I cannot find the end of this list. Oh, I see it. I didn't close. Good question. So yeah, it does. It returns this weird type though, a multiple. So it takes a single message, which is our query, and then returns a multiple message, and then we count them. I didn't fully understand what it was talking about with this single versus multiple stuff. It says, oh, okay, so single represents a single DOM node. We'll have to see what our query does. Thank you. Really appreciate that, Darren. We had actually a super great stream. We got rated with 44 raters by, gotta see if I can say, Simuleos. So that was cool. I'm gonna go follow them after the stream, and everybody should do that too. And a lot of them stuck around for quite a long time. So I think there's still some people hanging out. So thanks again. I really appreciate that. We got some interesting stuff coming up the pipe potentially. So I will let you know as soon as I know what's going on with that. So lots of good stuff happening. Very happy with the state of the stream currently. I made new emotes. If you haven't seen those yet, they're kind of fun, I suppose. They're little snails. Little snail. Little snail. Three little snails. Kind of cute. So yeah, lots of good stuff happening. All right, so anyway, we got this thumbnail rendered thing. So let's go look at this real quick because I don't fully remember this. No, I just like snails. They have nothing to do with anything other than I like them. Oh, I see what you're doing there though. That's very funny. I didn't think about that. We could use that meme though. I like that meme. We can make that a meme. I'm into it. So how do we source? Oh, okay. So this pulls out the thumbnail URL from here. So we could do this probably with the class as well, right? This is kind of the same idea, I think. I don't think that this is going to work though, because I think, well, we'll see. I think this will fail. It's not a test yet, but I think once we finish the test, it's going to fail, and I'll explain why in a little bit. But it's related to, it's really easy. It's really related to this. So we'll see. Because the thumbnails aren't read from large. They're read from the root URL. All right, where was I? Oh yeah, I was going backwards. Yeah, so hey Howl. So right now we're working on a Elm app from this book. So here, I'll show you just quickly. Here's the book. It's Elm in Action. So it's kind of just like an example program. And basically what it does is this. So it reads these photos from a server and displays them. So you can click the photos There's only 6 of them, but in theory you could just read from a whole bunch of them. And we can change the thumbnail size like this, and we can also add some effects. So that's basically what we do. We can do some ripples and some noise, and it's all live. So that's what we're doing. But it's just an example of like a single page app with Elm. And right now we're writing tests for it. You know what I just realized? I didn't change my title. My title's wrong, isn't it? It's been wrong this whole time. Yikes. Big yikes, folks. Sorry about that if you came in here with the wrong title. Nobody told me about it, so clearly you weren't reading that. Maybe you just saw this on Twitter or something. Manning, 50% discount on books. So yeah, if you want this book, you can get it for 50% off apparently. Here's the link for it if you're interested. Elm in Action. The first one is the link to the book. If you're interested in Elm, but there's a whole bunch of other books there as well. I can't think of any book that I need from Manning right now. I own all the ones I want, so one of the next books I'd like to do is the Haskell in Depth book, but it's not done yet. I don't know when it's going to be done, so we'll see. All right, so I think we fixed this, but let's just change this to prefix just to avoid any collisions. I don't think we'll have a collision. Like the compiler should probably complain about it, but not entirely sure, so we'll just do that. Okay, and then we have to write our test. And for reference, this formatting is from the Elm folks. I think it would be nice if we, you know, did the following maybe. Something like this anyway. Only because I'm working on a, you know, a pretty small screen actually. I prefer the shorter lines when possible. But again, it inserts so much white space, right? Like that's a lot of white space for quadruply nested thing. I would only do 2 typically. But anyway. Okay. Where was I? All right, so this kind of makes sense to me anyway. We're looking specifically for the tag image that contains specifically the source that's there. And again, this is only for the thumbnails, not for so the thumbnails are these 6 things. So if we counted all of them, excluding well, that's kind of tricky because you can only include, we would have to put a thumbnail class on these like we were talking about before, but we don't have that, so no big deal for now. All right, so now we're gonna apparently buzz this, and the interesting thing is apparently we don't even need images to test this, because it doesn't even need to go search for the image. It just needs to know if it's there. That's kind of interesting. I hadn't thought about that. That's kind of cool. We're only checking that the DOM is correct. We're not checking what it looks like. Fun. You see what I mean by I've never really tested stuff like this, so this is kind of interesting. Right. It's going to be a fuzz test. Buzz. Fizz. Int range. By the way, this is amazing. Look at that. I love this so much. I wish I figured this out earlier. I actually had a setting inside my NeoVim config that was turning these off. Fun, right? Okay. Okay, so now we have a URL count. Here's how we can convert from a URL count to a list of URLs. Sorry, what's going on here? All right, fuzz int range will generate a random integer for 1 to 5. We'll use it to build a list of 1 to 5 elements. Okay. Yeah, Ken, I'm using Haskell IDE engine actually, and I've had really good luck with that. If you've seen any of Chris Penner's streams recently, he's using GHCID, and as far as I can tell, the experience looks the same. Like, I can't really tell a big difference between our workflows. He's more proficient at Vim than I am, but like the IDE behavior seems about the same. Okay. I haven't thought about trying the other one just because this is working for me. So I don't really have a huge, benefit to trying it out. Not yet, anyway. Okay. So we need to clearly take that. Yeah, this isn't going to compile yet. The nice thing about getting the LSP working in Vim is just that it works for everything, right? Like, you basically just install the LSP and you're done, which is super nice. I've had very few issues once I got it working. To be fair, it took me a long time to discover NeoVim plus COC NVim, but once you get that set up, then it's fun to use Vim again. Although I shouldn't say that. I should say it just makes the experience a little easier. It's always fun to use Vim, for me anyway. Okay, so there's our URLs. And we're just gonna pass that to our initial model. So we're gonna, whoa, NewMade gifting 5 subs to Hamza, to Ken, School Bus, Unrelated Things, I don't recognize your name, and Dorman. Hey, welcome to the channel. NewMade's amazing. I think he's gifted like so many subs. It's, how many is it? 5 subs. He's a huge like important person in the channel. So everyone, if you could just thank NewMade, I'd really appreciate that. That puts us over our 10 subscriber goal as well, so that's awesome. Which reminds me, I should do I should also promote the fact that if you have Twitch Prime, you can sub for free once a month, and that would help me as well. You don't actually have to give it to me. You can give it to whoever you want. And then also NewMade for the 10 months. Thank you so much. Seriously, you're awesome. Very, very amazing for the channel, and amazing in general. What's photo from URL? So that's our view function from PhotoGroove on the right side there. Okay. So what is this complaining about, actually? It should just complain like we're not done yet. Oh, actually, I know what it's complaining about. We need an in. So that should fix that. And then what's this complaining about? This doesn't have enough parentheses. Agreed. What's photo from URL? It's got to be a function from over here, I guess, but I probably called it something different. Photo from URL. Do. I gotta remember what function this is supposed to be. I probably changed the name of it. I don't even see it over here. All right, so anyway, we're making a load of... I see. So the problem is we need a function that converts from a string to a photo, I guess. And I don't actually have that function. I'll just write it, I guess. So we need photo from URL, which will take what? A list? No, we're going to take a string and convert to a photo. And this will be an URL, and then we'll just create a photo. So URL equals URL, size equals an integer. It doesn't matter what these are actually, and a title, which can be whatever. Okay. So can't pass this through this pipe. I can't really see the error here. Does it show up here? It does not. So we will run Elm test to try and get an idea of what the error is. Oh, we're not done. We're not done. That's why. We're only querying from HTML. So I think what we want to do is use our thumbnail rendered to deal with our expectations. So what do we get from query from HTML? That's going to be that, and then we want the string, and the string is just our URL. So we'll pass thumbnail rendered to... We only have our count. Okay, so we can use this expect all function, I guess, to run these. So what we need is, we're going to use expect all, and then we'll look at this. Let me do the following. All right, so we have this something to expectation, something expectation, right? And the function we have above that thumbnail rendered function takes a string single query message to expectation. So we just need a string to single query message function to replace this subject, and we should be okay. So we'll have thumbnail checks, and we will write thumbnail checks, which will take a list query single message expectation. Oh, okay, I see. The let is, they're sticking the let inside, which is fine. I don't love it, but something like this. And then that way we can get rid of that code and this code and okay, what fails next? Put that in there. Okay, and then this works. So let's see here. So we're just taking a bunch of integers, appending PNG to the end of them. We're creating random photos. I don't remember this size and title thing, but I don't think that's the point here. But we need to create a photo, so we can just stick some garbage in here, because all we need to do is make sure that the URL works. The other thing is, this really needs to be prefix no, that just takes a list of photos. I don't need to do this. I think this will be fine. Although the size 0 stuff is confusing, but it doesn't matter. Size. I feel like this is wrong. Thumbnail size. Where does that integer come from? Where do I convert the integer to like a thumbnail size? It's got to be int 2 somewhere. Photo decoder? I do not remember where this happens. Got photos. It almost seems like I'm not even using that. What if I, oh, here's what I can do. Just delete this and see what happens. Okay, let's rewrite this function. See where it fails next. So we're not going to get S, so we'll get rid of this, get rid of this, get rid of this. Okay, what fails next? There it is. Oh, the size is the size in megabytes. That's what this is. All right, now I remember what it is. Size int or kilobytes. So in theory, it can 100% be 0 because it's just some random size. It doesn't matter what's in there. Okay, cool. I forgot what that was. My bad. What next? So we figured this out. Now that we've verified that thumbnails display as expected, we can move on to testing that they work properly when a user clicks one. Okay, so this should pass. Elm test. Yep. And then what we want to do is make sure they work when we click them. So that's the next thing. I don't know how we deal with clicking yet, but I need... And basically that was like DOM testing. And now we're going to test user interactions. And apparently we can do that with fuzz, which sounds pretty wild. So when you click a thumbnail, that photo becomes selected. Here we can benefit from the test coverage we've obtained through tests we wrote earlier in the chapter. We already have tests that verify the following. When the photo loads, the first one gets selected. Wait, do we have code that does that? Whenever update receives a clicked photo message, we don't have those tests yet. When the photos load, the first one gets selected. I'm confused. Maybe I need to write those, but we didn't get those from the book. Is it local? I suppose you mean the user interaction, and I would guess so. I think it's really just like we're going to simulate someone clicking a link by sending that message. So yes, I think so. Like, I think what we're gonna do is, I gotta look at my message type. What am I doing? MSG. Yeah. I think what we're gonna do. Oh, the beer. Sorry. Actually, I don't remember where this one's made. That makes more sense. It's... Yeah, it is local. It's from Hershey, Pennsylvania. So I don't live in Hershey, but I live near Hershey, so it's local enough. Called Trogs. Yeah. Oh, I'm not even sure that's how you pronounce it, but Prutz will tell us. Trogs. Yeah, like this. I'm sure that's not how you pronounce it. This is pronounced kind of like a U, right? So Trugs, maybe. I don't know. I mean, yeah, yes. About. I don't want to watch a video, sorry. You have to watch a video to find out, apparently. What if I click here? The beginning. Alright, so one night, over probably a few too many beers, they came up on a name. They combined their last name with Krug. Again, I have no idea. The Flemish word for pub. It's a combination of Trogner. What was it? Where did it go? Trogner, unsure, and Krog. Again, pronunciation. He is, yeah. Prutz is our pronunciation master. He tells me when I'm pronouncing things wrong, anyway. So, Flemish? Plush, whatever they are? Unsure. I don't know that it's that harsh. I mean, I appreciate it. You've helped me pronounce things, like, legitimately, so. I'm not mad about it. I appreciate it. Okay. So, yeah. Simulating clicks, I think, is what's going to happen next. Although, one thing that's very confusing is they say that we've done these tests, but I don't remember seeing these tests. So maybe we should just write them as an exercise and see if we can make it work. We'll do that. So, let me double check. So we've checked sliders. We've checked that the thumbnails are rendered, but we need to deal with the selected one. So I think what we're going to do is something like load our model with the loaded photos and then check to see which one's selected, something like that. So this is counting the thumbnails, and we want to say these are the thumbnail checks, but we want to do something very similar to this. So we'll change this to thumbnails first selected. Okay, and then why is this complaining? Oh, just unused variable. Sure. So we're gonna load the photos, and then we're gonna pass that to our view, and then we're going to query from HTML, and now we need to look for the selected one. Okay, so loaded, photos loaded, got photos, loaded photos, string. What's the string? It's just the name. And what does it mean to be selected? So this is our canvas. Apply filters. Status, select URL. Okay, so we just had this loaded thing. So we could just, I guess we could just check our status, right? We don't even have to check, we don't really need to check the DOM. I presume that in our view function, I don't use multiple windows typically. I usually just use split windows, but I have used multiple windows in the past. Yeah. I've tried using it, and in some cases it helps me a lot, but in other cases not so much. Oh, these are split windows. Yeah, so these are... Right, I can move back and forth. The problem is that JavaScript overwrites the canvas. So like... That's not a pure operation. So I don't understand what this means. We can't check that the first one's selected. How do we check that the first one's selected? You just check the model, but you're defining the model. So I don't understand what this means. The second one seems more reasonable. So let me explain the second one. Let's see if I can do this. So we don't need these. We might need that. So click photo. I swear we didn't write this function. We did the sliders. Test slider. No photos, no thumbnails. We did that. I'm just making sure I'm not crazy. Yeah, okay. So that's not even in there. So how do we I don't think there's a way to determine that it's selected unless we go back to our original one that where this is just an ID with selected URL. Like there's really nothing to test. It's like I guess cuz like we have to define this when we write loaded. So it's just going to be, you know, make the model and then check that the selected URL is the right one, but that's not part of our state, right? What is going on? Ugh. Sorry. Activity status, like the model has no concept of which URL is currently selected. So I don't really know what to do there. Click. maybe what we should do is just use click, like check that clicking a photo changes the string to the right one. Maybe that makes more sense. So that's what we'll do. Let's do that. So how do we do that? So we're going to generate an initial model, and then we need to generate the click. We do that with this thing. So we're going to update it with okay. We're going to call our initial model. We're going to update with click photo and a string. We also need to fuzz that, I suppose. Oh, well, we can just use the first one, right? So list dot first. Forget how to do this. First. Okay, so URLs. So first. So get first URL. Can I do this? So we're going to update it. Then we're going to view. Then we should query. Yeah, I don't see how we verify this. That's the thing. So it's not part of our model. All we can do is say that the model is loaded something with selected URL, I guess. But I guess we don't need view here. Maybe we just do this and then say expect equal so we should get tuple dot first to get the model, and then we'll get dot status, and then status should be equal to what? Loaded. This? All right, yeah, this needs to be get first URL. List photo. What are we gonna give this thing? We can just give it list string. And this is wrong. Sorry, I'm getting tired, so I'm moving to Haskell syntax. which is incorrect. And we probably need to do this actually. And this is going to take a list string and return a string. And then we can do get first URL URLs, or we can do first URL equals get first URL URLs. That's probably a better idea. And then first URL. All right. What's this complaining about? We need to remove the shadowing. So this will never happen, so we'll just do that. L I forget how to do this stuff. So I think it's a case. Hang on. If we look at update, yeah, it's case L of and then we can do hey Tom, thank you for cheering a little 3-leaf clover. Appreciate that. So we used to make fun of Tom for being a little leprechaun. Not literally, but he's kind of a short guy, but good friend of mine. Thanks, dude. Really appreciate that. I do. Today has been an extremely supportive day, which is awesome. So thanks, everyone. I am doing well. I hope everything's going well with you. Can you work remotely? I don't even know. Oh, nice. Okay. I wasn't sure. I was not sure. So that's good. Yeah, I've been just working from this computer, so it's been kind of nice for me. I like this computer better than I like my work computer. Although, supposedly I'm going to be getting a new one soon, so that will be nice. All right. Oh, so Tom, I don't know if you've even seen this, but this is the application that we're building right now. So it's from this book. So like there's these little things and you can change their size and then you can click them and then it shows them over here and then you can modify like with some filters. We can make them really rippley and remove the ripples and stuff. So that's what it does. And then if we click this surprise me thing, it will just click random photos. So what we're learning how to do right now is like, how do I test this application? Because I've never had to test like HTML applications. So we're trying to understand how you test this. And it turns out you can build, right? I think you know a little bit about like HTML, but there's just this structure inside a HTML page, right? And what we're doing is basically building this and then testing its shape. So it should contain certain things. So we're just making sure that those things are in the DOM is what it's called. Yeah, exactly. So we've already learned how to build this, and what we're learning about is like, how do you make sure that what you're doing is correct? So that's the idea. Tom's not a programmer, so we went to grad school together, but he does real stuff. I programmed. Well, I don't know. I wrote code. That's really weird looking. Yeah, real stuff. This is really strange syntax, but fine. Okay. So now we're saying basically what this test is doing is, yeah, like more real world. So we both did PhDs in chemistry, and he was doing more like reactions and bench work stuff. He can tell you if he wants to. Whereas I did all theoretical chemistry, so everything I did was on a computer, like simulations and things like that. So that's what it used to be, like an ongoing joke that, you know, they did real chemistry and I was doing fake chemistry or something. A good joke. All right, so what we're testing now basically is that when we load this page, we're going to simulate a click. So I'm going to pretend like I clicked this button, even though it's clicked anyway. And then we're going to make sure that after I simulate clicking this button, that this thing is selected. Maybe we should actually take the second one and not the first one. But we have to change our test a little bit. Let's do that, because by default, the first one's selected. So we're going to say we want at least 2 images, not just one. And then I think we can do sort of second like this, and we'll say that this is get second URL, and then get second URL, second URL. Yeah, this is the Ryzen 2700X. Bet you're happy about that. It's just cheap. I won't say why that's a joke, unless you want to. Yeah, it's a 2700X. It was on sale. It's been really good, actually. I've been very happy with it. Earl. Okay, so yeah, so when we load up this application, basically it will select this one by automatically. So what I want to do is simulate clicking the second one. That's the idea. There's 2 bits. Yeah, feel free to drop in whenever. I'm always happy to say hi to you. We should set up a meeting with the quote unquote 3 Musketeers. We haven't done that in a long time, so we should figure that out. I have a Zoom channel, so like we can easily use that. But we should definitely do that. All right, so we're gonna build. It's easy. Like, you download a client on your computer and use it. So yeah. All right, so yeah, we're gonna pretend to click a photo, and actually we're not really clicking anything. Oh yeah, we can use Discord as well. We could just use my Discord, but then that means the third person needs to use Discord, and getting him to do anything that he doesn't already do is always hard. He's a very particular guy. Yeah, okay, cool. So that should work, I think. And we'll see if this actually works. I have no idea. I'm guessing. We failed. Oh, okay, so this is just a naming problem. So we need to change this. So click photo, second photo. Click photo should return correct photo. Selected URL. Something like that. So that error was just a naming error. It wasn't like an actual test failure. Oh, nice. Okay, and then we should check to make sure that it's actually working by like writing 2 more functions real quick. So this is a fun little exercise because we're learning a little bit. Okay, so if this should not be equal to the first URL, get first URL. Clearly I should probably do something different here, but it's fine. The problem is if I use the list.get syntax or whatever it is, there's a way to like access a list by number. It returns a maybe, and then I have to match on maybe. So I'm trying to avoid that if I don't have to like deal with it. I know that I'm going to get at least 2 of these, so I can pattern match pretty safely and get, you know, the thing I need. Oh, except get URL first is implemented incorrectly, so it would have failed. There we go. So now we're saying click the second one and it should be equal to the first one, and that should not be true, so this should fail. Sanity check, basically. Very nice. So you can see that loaded contains two URLs, 1 and 2, and the state is this, but it should be equal, or it got this. So yeah, it seems to be working. And just, we can get rid of this because it's unnecessary now. I just wanted to check second URL. Okay, so this is really thumbnails. Click photo works. I don't know. Click photo works. What'd you learn? New Vim key. I like new Vim keys. Actually, I have another book back here because as you probably know about me, I'm kind of a book collector. Oh yeah. That's a good one. I've seen that before. Actually, Strager was doing some interesting like coding last 2 weeks ago maybe, and somebody showed him how to increment like a whole entire line visually. I thought that was really cool. I forgot how to do it already, but there's a way to like change a number. You know, if you put like it had a bunch of 1s, you could change it from 1 to like 20 in visual mode. Looks pretty cool. I've never done it before, but it looks like a useful function. I don't even remember what he was working on. It's something related to bash. There's like a bash error he was trying to fix. Like there's a between 2 versions, something was broken with Homebrew. I don't know what he was doing. Okay, so we tested this. This works. So when photos load, the first one gets selected. Okay, so this is what we tested. Whenever update receives a clicked photo message, that photo becomes selected. And actually, we can do the other one because it's just the first URL one. So it's really like abstracted over, like, I'm not going to write the abstraction, but thumbnails loaded first selected. So we can easily write this one now. Loaded first selected. We just take this. URLs photo first and then we'll remove the update, and we'll load this. We'll call loaded. No, what we'll do is call loaded. What is it called? Got photos? So we're gonna say initial model update got photos okay, and then the list of photos. So actually we don't even need this first URLs function. We just need URLs, and then we'll check the status. Oh, I do need that function. Shoot. URLs, pull the status out, and then the first URL should be loaded. Oh, right. So we need to embed this into something. That's like a type. So let's look at okay. 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 This passes if the result is an okay. Returns successfully parsed value. No, this doesn't work. So let's look at result. Result. Elm HTML. Result. Where is that from? Where's okay coming from? Let's, how do we, can we use holes? Undefined? How do we make this compile? I don't even know. I think what we do is just say I don't remember how to do it. I'm confused and tired. Apologies. Okay. We gotta go find this okay thing. Got photos. Expect JSON. It is an HTTP. Result. So how do we create a result? That's the question, right? Result. Type. So, I don't know. A to result AB. Singleton. Create. Well, this is in result extra. maybe I need this function. Let's go look at it. I might be able to just write this real quick. Result extra. Combine singleton. How do I bring up source? Confirm. Let's just get their code. Singleton. You just give it, yeah, okay in the thing. Why doesn't that work? That's what I thought. Okay. Maybe I need to write result.okay and then URLs. Oh, it's probably because it's a list of photos. So got photos. Yeah, it's a list of photos. So I need to do list.map photo from URL URLs. And that should compile. But clearly if I'm going to do this, I should do photos equals list.map photo from URL URLs photos should have done that differently, but too late now. Photos. Okay, so I think that this works. Kind of had to write a lot of code to make this work, but I feel like this is correct anyway. Our get first URL thing is wrong again because we didn't change it. So it's just like head. Something like this anyway. Ow. All right, let's see if it works. Test. Failed. Oh, same name issue. So got photos should return. Sure, that's probably correct. Elm test. Again, names I'm less concerned about. Sweet. And then we can make sure that what I'm doing is not insane by just saying, you know, derp. Elm test should fail. It does because we got derp and not the first PNG. First URL. All right, cool. So we turned this into some exercises. So like, I'm really excited about that because there aren't any explicit exercises in this book, which is unfortunate, but like, it is what it is. There's not much I can do about that. So now that we have that, we're good to continue. But I think that's it for today. We've